What I'd like to share with you today morning is a piece of research at the Massachusetts General Hospital in US, which, if it culminates in success, would lead to creation of a generation of superhumans resistant to all infections. I mean, naturally resistant to all infections. Amongst the beta cells responsible for immunity, you have the B2 cells, which actually produce antibodies when a pathogen invades the system. So it takes its own sweet time to create antibodies. But there is another group of cells called B1 cells, which are born with immediate capacity to produce antibodies, which can prevent invasion by any pathogen. But now we are going to get into a little bit of complex ultimate research areas, which might seem complex, but then the gist of it is rather simple. See, scientists were trying to find out what exactly is the epigenetic difference between B2 and B1 cells. If we had a lot of B1 cells, we would be creating a generation of superhumans resistant to all infections. But then in the epigenetic process, there's a step called CpG methylation. See, CpG methylation stands for 5-C-phosphate G3 methylation, which, if further expanded, is 5-cytosine phosphate guanine 3 methylation. This process which differentiates B2 and B1 cells. Now, you may wonder why we can't have a good number of B1 cells so that we are naturally immune to all pathogens, invading pathogens. The problem is, if B1 cells are allowed to proliferate without a break, it would definitely lead to cancerous conditions like chronic lymphomic leukemia and things like that. So the genetic system puts a brake on the proliferation of B1. This brake is called DNMT3A. DNMT3A is the brake which stops the proliferation of B1. Now this stands for DNA cytosine 5 methyltransferase 3A. DNMT3A is DNA cytosine 5 methyltransferase 3A, which is a brake on the proliferation of the B1 cells. Now, if you think logically, if we can apply this brake at a point where we have enough B1 cells to resist all invading pathogens, but not enough to lead to chronic lymphomic leukemia and other complications. Okay, fine. So if we can put the brake at the right time, we could probably create a generation of superhumans resistant to all invading pathogens. Research is proceeding in this direction. Let's wish them all the best. Thank you very much.